Greetings to all. The session is regarding intermediate chemistry. Will be fetching for your entrance and competitive exams on the international floor. India is conducting JEE Advanced. JEE means examination and NEET exam for medical entrance. All these across the India conducted by National Testing Agency in order to get admission into engineering by JEE and NEET for medical entrance exam. Telangana and Andhra Pradesh government are conducting the exams called MSET, where BTech admissions will be obtained by this kind of entrance. In addition, if you're aspiring for any government organized job opportunities, there the consent is regarding general science question paper. General studies will be there, and in that general science questions are available. The content we are discussing is very much fetching for that kind of preparation. Let's enter into our today's session. The Nobel Prize in the Chemistry 2007 was awarded to Gerhard et al. For his studies of chemical process on solid surfaces. It is a part of surface chemistry where 2007 Nobel Prize in the field of chemistry was accorded for the scientist. He is the scientist Gerhard et al. And contributed a single person accorded with the Nobel Prize in the year 2007. And his brief info is provided over here. Royal Swedish Academy for Sciences have decided to award the Nobel Prize in the field of chemistry for 2007 to Gerhard et al., Friedrich Haber Institute der Max Planck, Gesellschaft, Berlin, Germany. He belongs to Germany, and this is the kind of what university worked over, and he's the scientist worked upon solid surfaces. For his studies of the chemical process and the solid surfaces is the concept taken into the consideration. Modern surface chemistry, from the artificial fertilizers to the clean exhaust. The Nobel Prize in the field of chemistry for 2007 was given to that scientist who accorded with the esteemed Nobel Prize because of his contribution in the field of solid surface chemistry. As a groundbreaking studies in the surface chemistry, this science is important for the chemical industry, can help to understand such varied process as why iron rusting. Iron rusting is the common process everybody aware, that is the kind of corrosion we can see. And fuel cell working will be there. Fuel cell is a kind of device where fuel energy got converted into electrical energy. It is the most important kind of device, electrical device in an environmental protection perspective, and how the catalysis in a cars able to work. Chemical reactions and catalytic surfaces play a vital role in many industrial operations, such as production of artificial fertilizers. Surface chemistry can even explain the destruction of ozone layer, vital steps in the reaction actually taking place, right? So this is another breakthrough we can notice by means of solid surface chemistry, that is artificial fertilizers. How fertilizers will be manufactured? Generally, fertilizers are available in the natural source, even we can synthesize in the laboratory, which are termed as artificial fertilizers. Being land is limited, we need to supply the nutrients continuously, then only there is a high extent of crop yields are possible. The semiconductor industry, yet another area, depends upon the knowledge of surface chemistry. It was thanks to process developed in the semiconductor industry that modern science of the surface chemistry began to emerge in 1960s. The concept of surface chemistry emerged and expanding since the 1960s. Gerhard et al. Was one of the first to see the potential of new techniques step by step. He has created the methodology for the surface chemistry by demonstrating how different experimental procedures can be used to provide the complete picture of the surface reactions. The science requires advanced high vacuum experimental equipment as aim to observe individual layers of atoms. Molecules behaves extremely pure surface. So purely how the reactions are carried over the surface regions, how extent advantages these exclusive study got done by the scientist called Gerhard et al. And the study was began in the year 1960. Surface chemistry concept was originated in early 1960s. This is the way exploration got carried, and much more applications we can notice rather than a single specific. Surface chemistry is the kind of platform in order to go for multi-dimensional applications. You may go with the fertilizers, semiconductor industry relying upon, and fuel cells working based on this surface phenomenon only, and rusting, how it is possible, and how depletion of ozone layer. All these concepts are much more clearly studied by means of this kind of new route of chemistry. This is the way we gone through the Nobel Prize, esteemed Nobel Prize in the field of chemistry for the year 2007, world recognized laureation for the excellence in terms of innovation, we can say. Gerhard Uttel was a scientist who was accorded with the Nobel Prize in the year 2007. Let's move on to another question, that is, here you can notice how the process of surface chemistry is possible in contrast to the absorption process. Surface chemistry purely relying on the process called adsorption, and the bulk phenomenon is called absorption. Adsorption purely applicable to the layer upon the solid, and either it might be monolayer or else multi-layer are possible, but they are not entering inside. They are purely reacting on the surface. This kind of invention, this kind of strategy got done by the scientist, so that he was accorded. And here is the process called another one called absorption, where molecules are able to shrink inside so that the molecules, this kind of phenomenon is called bulk phenomenon. The surface phenomenon is more advantageous over this bulk phenomenon. That's the reason why it finds multi-dimensional applications. Let's move on to question number 2, which is collected from the Cambridge Assessment International Education. Elements and the compounds which have the small molecules usually exist as the gases or else liquids. Chlorine is a gas at room temperature, whereas bromine is a liquid under the same conditions. Explain the reason and observations. The gases nitrogen and the carbon monoxide are isoelectronic in nature. That is, they have the same number of electrons in their molecules. Suggest why nitrogen has a lower boiling point than carbon monoxide. 2 questions to be addressed. Let's go one by one. First question is regarding chlorine is a gas at room temperature, but bromine is a liquid at under same conditions, right? Both are the kind of molecules, we can say, which are the part of 17th main group, and that is called a halogen family, right? Though both are residing in the same family, but chlorine is the gas, but bromine is the liquid at room temperature. Even you move on to iodine, so that iodine is a solid in nature. That purely because of 2 reasons. One is called intermolecular forces. Chlorine is attached by weak intermolecular forces, whereas bromine are having stronger. Smaller the size, lower the atomic weight, hence they exist in the gaseous state. That is related with the chlorine. Both the factors are implicated for chlorine is the gas because of weak forces of interactions, and smaller the size it will be. Bromine, being it is a larger one, atomic weight increases, so that attractive forces are more in nature, so that it is in a liquid form, right? This is the way we can answer both the first question, and move on to second question. The gaseous nitrogen and carbon monoxide are isoelectronic. Any species are said to be isoelectronic when both are resembling with their same number of electrons in their valency shell, right? So any 2 species are having equal number of electrons, that is said to be isoelectronic one. Nitrogen and carbon monoxide. So if you see nitrogen atomic number is 7, so that 7 electrons in one individual atom. When 2 nitrogen atoms are combining, 7 plus 7, 14 molecular orbital electrons are resided. If you go with carbon, let me count. Carbon atomic number is 6 and oxygen atomic number is 8. So that 6 electrons resides in carbon and 8 electrons contributed by the oxygen. 6 plus 8, again you can go with 14 electron system. So that the molecules nitrogen and carbon monoxide are having equal number of electrons from ground to valency level. So that both are said to be isoelectronic. Though both are isoelectronic in nature, but nitrogen nitrogen is non-polar because two nitrogen atoms are exactly equal, and both whenever they are forming the bond, the bonded electrons retains exactly in between the two nitrogens, and both are equally sharing. There is no polarity. The bond displacement may not occur. The molecule cannot exhibit dipole-dipole interactions, being it is a kind of homonuclear, so that the bond is non-polar in nature. Attractive forces got minimized. Dipole-dipole interactions are much more in case of carbon and oxygen. Being carbon-oxygen varies in their electronegativity values. That's the reason why slightly bond displacement towards oxygen atom, being oxygen more electronegative in comparison to the carbon. That's the reason why there is a kind of dipole-dipole interactions you can notice, and which are highly stronger in case of carbon monoxide in comparison to the nitrogen. That's the reason why carbon monoxide expected to have high boiling point value. In order to break the bond, being it is highly stronger bond, in order to break, a high boiling point is required for carbon monoxide. Being non-polar nitrogen, that molecule comparatively having low boiling point values. This is the way we can answer both the questions. Hopefully, both are very clear to each and everyone. Let's move on to question number 3. Question number 3 collected from JEE Advanced Question Paper 2016, Paper 2 question it will be. The major product of the following reaction sequence is, this is the part taken from the organic chemistry and moreover carbonyl compounds. This is a ketone where benzene directly linked with the ketone, and this is said to be isobutanone. Right. A formaldehyde treated in the excessive amount under alkaline conditions and rising the temperature so that heat is also provided over there in the condition number 1. Move on to condition number 2. HCHO again formaldehyde solution was treated but under acidic condition. This is called catalytic amount. This is not excess, rather catalytic amount was treated over there. If this is a kind of reaction carried on this ketone, aromatic ketone, we can see the expected product among all. So all are having benzene ring, so that we are not supposed to an effect that benzene ring. In the side chain, there is a possibility of this kind of acetal cyclic ring formation you can notice, or else here ketone having in either side chain where two oxygen atoms got attached because we are adding two formalin molecules, right? And here also in either molecule you can notice already existing oxygen is giving one of the hydroxy, and new coming formalin solutions are giving two oxygens as per this option. In either option, you can notice two oxygens. One is in ketonic form, in either hydroxy, and in either hydroxy will be there on benzene ring. These many possibilities they provided. You can cancel out option D blindly because there is no possibility for aromatic substitution. No way Lewis acid or else any Friedel-Crafts reagent or else any catalytic conditions are not provided suitable for aromatic substitution, so that wherever aromatic substitution you can cancel out. Option D, aromatic substitution to be cancelled, and move on to either options. Among option A, C, B, we have to trace out. The expected answer is A. Let's see how can we go with its mechanism. Here is the starting material called a ketone. One side we have alkyl, in either side benzene ring will be there. We can say it is an unsymmetrical ketonic molecule. Whenever treated with formaldehyde under basic conditions like sodium hydroxide, this is a kind of formalin solution will be added over there. And here you will get CH2OH, alpha beta unsaturated, alpha beta unsaturated. We can't say alpha beta unsaturated. This is a kind of beta hydroxy ketone will be generated. Sorry, beta hydroxy ketone will be generated called aldol condensation, right? So whatever generated can be treated with a formalin solution, so that wherever we have a ketone, that will be turned into a hydroxy. Later on, we can treat with a formaldehyde again, so that it will participate in our ring cyclization reaction, so that we will get, this is a molecule said to be acetol. Acetol in the sense wherever hydroxy are present, which further alkylated, that is said to be a acetol kind of thing. And it is a cyclic one. We can say even cyclic ether as well. So it is the acetol formation. You can clearly notice that acetol is having two methyl groups over this carbon, and next carbon is attached to the benzene, and the next atom is oxygen. Being it is a heterocyclic ring, aliphatic heterocyclic ring, we can say two oxygens are joined with the CH2. This is the way the ring system acetol form. You can clearly notice in the option number A only. Option C, we can't take it as an answer because here neither hydroxy is also present. This may not be correct. According to the prescribed mechanism, the expected answer is option A. For question number 3, option A will be the correct answer. Let's go with the question number 4. Again, it is collector from JEE Advanced 2016 paper 2 question. It will be, in the following reaction sequence in the aqueous solution, the species X, Y, Z respectively. Here we are taking S2O3 minus 2, which is called hyposolution. Simply you can write it as Na2S2O3, that is called the hypo. Sodium thiocyanate is the chemical name of hypo Na2S2O3. Which can be written in the form of ionic S2O3 minus 2. It's treated with Ag+. It's a kind of volumetric analysis. We can say Ag+ will be added with this S2O3 minus 2 ion, and you can observe a clear solution. Being it is water soluble, silver compound, whatever generator, will be water soluble, so that clear solution will be obtained. Still, you are adding excessive amount of silver, so that white precipitate, it will be saturated. Whenever it is saturated, that obviously go to the bottom as a white precipitate. Later on, as the time passes, whichever white precipitate is there, that slowly turn into a black precipitate. From this only you can obtain a hint, black precipitate obviously of sulfide. Wherever sulfides are there, those options might be correct. We will go with either option A or option B, because black color is achieved by the formation of sulfides of the silver. Everybody aware that whenever you can take the silver articles or silver ornaments which placed in the open air for long time under moisture conditions, you can obtain a tarnishing that is called a corrosion of silver. Black colored dots you can notice, that is because of sulfide formation of the silver, that is called a kind of corrosion for that, right? So there is a possibility of A or B. You can cancel out this as a metallic silver and here metallic silver. Metallic silver is lustre white color. Everybody aware how the silver exists. So that a black precipitate they are saying, so that black may not be achieved with the metallic silver. So cancel out C and D. Let's move on to either A or B. So among all, option A is the correct answer. Let's see how can we get this. In order to get that one, take 2 moles of hyposolution called sodium thiocyanate S2O3 minus 2. Treated with silver ion, and there is a formation of complex. The complex will be AgS2O3 taken twice, because here we have bivalent hyposolution and silver is monovalent, so that we have to balance the stoichiometry. AgS2O3 taken twice and whole to the power minus 3 will be taken, and more silver if added, that will be dimerized. Silver is added with one more, so that Ag2S2O3 will be formed, and Ag2S2O3 is a kind of saturated one, so that we will get a white color precipitate. As time passes slowly, that silver will be oxide silver. Here you can notice Ag2S2O3 is a kind of oxide form. Now it will be turned into Ag2S, that is a kind of reduction, we can say. How it will be oxygen slowly evaporated, so that Ag2S is the kind of black color precipitate, is a kind of reduction, we can say. This is possible and the option A only. For question number 4, option A is the correct answer. AgS2O3A2 minus 3 will be the clear solution, water soluble. As excessive silver ion is added, that will give Ag2S2O3. And that white precipitate, as time passes, will evaporate oxygen, gives rise to the sulfide. Sulfide will turn into a sulfide kind of a salt. That is given in the option A. For question 4, option A will be the correct answer. Let's go with question 5. It is collected from the IMCIT examination for BTech entrance conducted in the year 2020. A benzene derivative did not produce white precipitate with ammonical silver nitrate solution, but decolorized cold dilute alkaline camphor solution. The compound is ఒక బెంజీన్ ఉత్పన్నము అమ్మోనికల్ సిల్వర్ నైట్రేట్ తో తెల్లని అవక్షేపాన్ని ఇవ్వడం లేదు, కానీ చల్లని సజల క్షార క్యామెనోఫోర్ ద్రావణాన్ని వివరణం చేసింది. ఆ సంయోగ పదార్థము. Right, the question is given in the bilingual language, English as well as Telugu, so that here the compound that is the benzene derivative. Benzene derivative was taken, and here two distinguishing reagents are provided. We have to get the awareness regarding what application we have for ammonical silver nitrate and what application is there for alkaline camphor solution. Ammonical silver nitrate is a kind of, if you go with the carbonyl compound that is called tolerance reagent for distinguishing aldehydes from ketones. In case of here, if you observe all the options, that is a kind of hydrocarbon only. In case of hydrocarbon, again ammonical silver nitrate have its role to distinguish terminal alkynes. Terminal alkynes are nothing but whichever triple bonded carbon is having that at the edge, the triple bonded carbon is having at the edge, so that the hydrogens which are residing on the triple bonded carbon are called acidic in nature. Those acidic hydrogens can be grabbed by ammonical silver nitrate. That is the work we can achieve by this ammonical silver nitrate for unsaturated hydrocarbons. Right, so they are saying that benzene derivative did not produce white precipitate with ammonical silver nitrate. That means terminal triple bonded carbon is absent. That part we have to notice. Wherever triple bond is there, you can cancel out that. But decolorizes cold dilute alkaline camphor solution. This indicates cold alkaline camphor solution is the reagent called Bayer's reagent, which is the distinctive test to identify whether unsaturation is there or not. It might be double bond or else a triple bond. But wherever unsaturation is there, that will be treated with camphor, giving rise to a vicinal dihydroxy compound by decolorizing the pink color of camphor. Whenever solution was taken, added 2 drops of camphor solution, and by shaking, if color disappears, that indicates the solution is unsaturated, being it is added with the camphor and dihydroxy compound will be generated. This is the way the positive test for Bayer's is indicating there is unsaturation, but negative test for ammonical silver nitrate is indicating triple bond is absent. Terminal triple bond is absent. Obviously, you can go with the option C8H8. C8H10 we can cancel out because it is saturated. So unsaturation is confirmed by alkaline camphor test. So that cancel out this C8H10. C8H6 also we can cancel out, being it is the negative test ammonical silver nitrate indicates triple bond is absent. C8H6 obviously triple bonded compound, so that you can cancel out option 1 as well. C7He8. All right, C7He8, if they are saying there is no such kind of provision we have for this reaction. Let's see how can we achieve this. Bayer's reagent is called cold alkaline camphor solution. It is the identification test for unsaturation present in the hydrocarbon. It might be triple bond or else double bond, whichever present, that will give the positive test with alkaline camphor. Decolorizes the pink color and silver nitrate, any other reagent called silver nitrate, acidic hydrogen, alkynes, and makes the white precipitate. Wherever triple bond is there, only this reaction is positive ammonical silver nitrate test. Among the options given, only the provision is C8H8 is having the styrene ring, where the double bond is there in the outside of the benzene ring. Being benzene is also unsaturated, we can't say that will give. If benzene added with Bayer's reagent, can you find any positive test? Absolutely no, because benzene, though double bonds are present, which are not a kind of simple double bonds, rather they participated in aromatic gester, so that Only the double bond whichever present outside the benzene ring is responsible for the reaction with the base reagent CaMnO4 and giving a vicinal dihydroxy compound. So this is the way decoloration of pink color of alkaline CaMnO4 solution is possible. That is absolutely correct with the option number 3. For question number 5, option 3 is the correct answer. Let's move with the last question of the session. Which of the following can be used as a test for unsaturation with regard to the color change of the reaction? Again, it is a part of identification test for unsaturation, color change test for the unsaturation that to be identified. ఈ క్రింది వాటిలో ఏ వర్ణ మార్పిడి క్రియతో కూడిన అసంతృప్త పరీక్షగా ఉపయోగించవచ్చును? సో హైడ్రోకార్బన్ లో అసంతృప్తత ఉన్నట్లయితే ఏ కలర్ చేంజ్ రియాక్షన్ వల్ల మనం దాన్ని ఐడెంటిఫై చేయొచ్చు అనేది క్వశ్చన్, right? So here addition of hydrogen, absolutely no, because hydrogen is not used for color change. Hydrogen will be added wherever double bond or triple bond is there. Addition reaction is possible, but identification is not possible. We can't observe the color change before and after. Hydrogen is a blue color gas. Whenever added to double bond or triple bond, we can't notice any color change, so that this can be cancelled when hydrogen bromide solution. One side hydrogen, one side bromine will be added, so that will not give the color change of the reaction, so that we can trace out, cancel out this option 2 as well. Hypobromine amla sankalanam, addition of hypobromous acid. Hypobromous acid also not giving any kind of color change reaction. Rather, bromine, addition of bromine is only the absolute answer for this question number 6. Let's see how can we achieve that. Any solution of unsaturated was taken. We don't know whether it is unsaturated or saturated. Add a few drops of bromine water to the solution, so that bromine color persisted. That means bromine color, brown color persisted. That indicates the compound is saturated in nature. If by shaking bromine color changes, so that we can understand the color, the compound is unsaturated in nature. Organic compound to be tested, taken in the test tube, dissolved 2 ml of distilled water. Whichever compound was taken, that will be added with the 2 ml of distilled water over there. Bromine water drop by drop is added by constant shaking as shown in this figure. If the orange red color of the bromine disappears, then organic compound is said to be unsaturated. Here two provisions we have, two probabilities we have. One is either retaining the color of the bromine or else color is completely decolorized. If color pertained, that indicates saturated one. If color completely disappeared, indicates unsaturated. By this color change, you can notice that unsaturation in the compound. That question number 6, option 4 is the correct answer. By this, we entirely completed the session, where various concepts are taken into the consideration and the examination perspective. Previous year questions are collected and detailed explanation is provided with the informative manner. Authentic websites are taken into this consideration in order to collect this valuable information. Hopefully, every concept is very clear and multi-sectors of multi-sectors of the intermediate chemistry got covered over there. And I'm requesting you to like the channel, comment. In order to comment, there will be a question regarding which topic we will take, surface chemistry. In case of surface chemistry, we gone with the adsorption process. In adsorption process, charcoal is a better adsorbent, we can say. Can you explain the medicinal applications of charcoal? Medicinal applications of charcoal in the context of surface chemistry. That to be taken as the question for the session and to be commented in this box. Share with these parents who are more serious about the education and examination for any entrance or else any competitive exam as well. And subscribe the channel. We will go with the new content in the near future, so that we will achieve, we will go with that concepts which are very clear to you if you subscribe the channel. Thank you. Thank you for watching.